Hello. In this video, we will learn about the behavior of rational function. In this case, we have like 1 over x right here. So the graph is, you see that we learned about the basic function before. So the graph would be in this way, it had two branches and they're not connected. So it disconnected right here. So when we see this one right here, you see the function as it go to 0, well, value of x go to 0, look like it go forever on the top. So let's see here, if I put right here, x equal, I put something small so that we can see right here, 0.5, right here. So x equal to 0.5 and then y equal to, so you see the point right here, huh? So then I can make this one into smaller, so let's say 0.3, 0.4. Maybe I can see something right there, right? And you see, if I move this point closer to closer to 0, you see this number here get closer to 0, not quite close, but it go all the way over here. You see it's very close. So now let me see, I put over here, that would be put over here, let's put 0.1. And you don't see it anymore because it's all the way up here. But if I zoom in, you will see the point right here. It's like 10 is right here. Now, if I put a little bit smaller, I put would be like 0, 1. So you see that's 0, 1. So very closer to 0, huh? And you see it here 100. It, even further up, you see, let me zoom in, you can see right here. So almost this one is just like a line at all, right? But actually it's not. So the closer we have the value of y, it go to infinity big. So that's why they have that part. Now let's see if we do it to the right. See what happened here. I'm gonna do it will be negative 0.01, and you see where the point that will be. This one also negative 100. And if I zoom in, you will see the point it can be down here. It's zoom right here. I mean, it's all the way down here. So that means basically when it closer to the 0 from the left, that be negative 0, 0, 0, whole bunch of 0, and then 1 at the end. So then you see this number get really big. Let me put another 0 in here, and you will see right here. Yeah, as you see that in 1,000, I put another 0, you will see it's negative 10,000. Yeah. So right here. So you see that. Therefore, they said it like they say at x go closer to 0, then this value here, it go to 0 to the right, and the function go to infinity, right? Positive infinity go up. And if x go to close to 0 to the left, then this one all the way down. You see the arrow down here is indicated, go here. But it never 0. It close, I mean, it never 0. You close to 0, but not never 0. Then your answer over here, negative infinity, that you have that. Now, what happened if my x, let me zoom it back right here for you. Okay, what happened if my x equal to 1,000? Then what in my y value would be? Oh, they didn't let me go to 1,000 here. But if I get it go big to this way, then you will see the answer over here that can go closer to 0, right? So I have 5, it go to 0.2, and they go smaller, it's gonna go to very, the further to the right I go, it's going to be closer to 0. And same thing, if the further I go to the left, with negative infinity, my answer would be 0. So therefore, they have over here, they have this notation right here for you see right here. At x go close to 0 plus, that means it's to the right side of 0. That means 0 point, a whole bunch of 0 and put 0, put the 1 at the end. So the answer would be positive infinity. And if you go close to 0 to the left, which is negative infinity, you have the symbol here. That means that's way. And then as you go to infinity this way, like huge number, like million, a trillion, is trillion, all that thing over there, and you see the answer f of x equal to 0. And same thing over here. If you go to the right, then the answer will be negative infinity, then your value can be very close to 0. So these things here, whenever you have that one right here, you go to close to 0, and one way go to positive infinity, and here negative infinity. This one they call a vertical asymptotes. And this one over here, they call horizontal asymptotes, as you see they mentioned right here. So vertical asymptotes. you cannot put 0 in here, because if I put 0 here, you put in your calculator 1 divided by 0, it doesn't work. So that way you have vertical asymptotes. So at the same way that you will find the domain later, whatever you do, vertical asymptotes here, you will set the denominator equals 0, and then you solve for it. That's where you find the vertical asymptotes. So let me see over here. I'm gonna move this one. I'm gonna make my function become like this. Yeah. So my function become like this: 1 divided by 1 minus x. So you see right here, a plus x. So my, let me zoom it out a little bit so you can see right here. So this value right here, if I put -1 in here, the bottom become undefined right here, huh? But if I put the value closer to -1, let's say I put over here, that would be -1. I'm sorry. I'm gonna show it gonna be instead of do -1, I'm gonna do the right -1 with the -0.999. Yeah. So you see right here, my answer again, it go really big on the top, all the way over there. And if I put 1.001, I'm sorry, negative 1.001, that means to the left of -1. Yeah, a little bit further to the left right here. So my answer will be huge negative number that you see right here. So therefore, x equal -1 would be my vertical asymptotes. Right, so I have in there. Yeah. Now horizontal asymptotes would be same thing you have right here. Horizontal asymptotes, as you go to infinity or negative infinity, your function go toward to a number. So that would be your asymptotes that you see right here. So you see this one here. So at this one go closer to 2, then you have on the right up to, you go to infinity, and you go to the left up to, they're gonna be go negative infinity. But if you go toward to infinity, your value will be closer to 4. And you go to negative infinity, also go to -4. So you have here on the function here, you have a vertical asymptotes at x equal 2, and the horizontal asymptotes at y equal 4. So that's what you have in there. So I hope it helped to explain the behavior of rational function. And then you can go down all the question in the homework. Then you can explore more the application of the behavior of rational function to graph and to checking the value in infinity.